In modern warfare, probably the single biggest challenge for a commander is seeing the entire battlefield at once. I mean, think about it. What if you could take satellite images, drone feeds, and intel from the ground and fuse it all into one single, live, interactive map? Well, that's exactly what a Geographical Information System, or GIS, does. And today, we're going to break down how it gives a commander that ultimate digital edge.
You can almost think of GIS as the ultimate decision support system for military leaders. It takes this just chaotic flood of data and somehow transforms it into a clear tactical picture. So let's get into how this system captures, stores, and analyzes all that location-based data to give commanders a really critical advantage.
So here's our game plan. We're going to start with the why, from a commander's perspective. Then we'll get into the real nuts and bolts, what GIS is, what it's made of, how it works, and we'll see it in action. Then we'll wrap it all up with the most important takeaways.
All right, let's dive right in and set the stage.
Okay, so before we even add the geo to GIS, let's just talk about a plain old information system. At its core, it's really just any organized system. We're talking people, hardware, software, that all revolves around a central database. It's the engine that makes sense of all that raw data.
Okay, so we've got the foundation. Now let's add that all-important geographical layer.
So what is a GIS exactly? Well, it's a very specialized system, and it's designed specifically to handle geo-referenced data, which is really just a fancy way of saying data that's tied to a specific location on planet Earth. Its whole job is to capture, store, analyze, and then finally display that information in a way a commander can actually look at and use.
And you might be wondering, how does GIS keep all this straight? Well, it organizes everything on two really simple planes. First, you've got the spatial plane. This answers the question, where is it? It's your classic latitude, longitude, and elevation. But just as important is the temporal plane. This answers, when was it there? So every single data point gets both a location and a timestamp.
Okay, so we know what a GIS is supposed to do. Now let's pop the hood and look at the three fundamental parts that actually make it all work.
So any GIS really stands on three pillars. First up is the hardware. This is all the physical gear, right? Your computers, scanners, satellites, all of that. Second is the software. This is the interface, the screen, and the buttons the user actually interacts with. And third, and maybe most important, is the database. This is the digital brain of the whole operation, where all that location and time data gets stored.
And you can see right here how it all connects. At the very core, you've got the user, who's interacting with the software to get at the database. The hardware is sort of this outer ring that makes it all possible, connecting all the parts and letting them talk to each other.
So we know what it's made of. Now let's walk through the step-by-step process of how a GIS actually does its job.
A GIS basically works in three main phases. It all starts with the input phase, where it's just pulling in data from everywhere: satellites, drones, UAVs, even old scanned paper maps. Then comes the really critical part, processing. This is where the system crunches all the numbers and finds the important patterns. And finally, you get the output, a clear, usable intelligence product that a commander can actually use to make a decision.
Let's just zoom in on that processing phase for a second, because this is really where all the magic happens. First, all that raw data gets converted into a standard digital format. Then it gets organized into something called a layered architecture, and we'll talk more about that in a sec. And finally, the system runs all these powerful analysis tools to answer critical questions like, what's the line of sight from this hilltop? Where's the closest water source? What's the absolute fastest route from point A to point B?
So this idea of a layered architecture is absolutely crucial. I want you to imagine you're stacking transparent sheets of glass on top of each other. The bottom layer, that might be your base satellite image. Then, on top of that, you place another sheet, and this one shows all the terrain data, hills, valleys, rivers. And then on the very top layer, you overlay real-time data showing where all your troops are. When you look down through all three layers at once, you get one single integrated GIS map with a complete picture of the battlefield.
Okay, we've definitely got the tech down. But how is it actually being used in the field? And what are the rules?
For a tool this powerful to actually work, you need rules. Otherwise, it's just total chaos. That means standardization, making sure everyone is using the same base platform. It absolutely requires strict security to control who sees what data layer. And crucially, it needs a common symbology, a universal visual language, so an Army unit and an Air Force unit are looking at the exact same map and understanding it in the exact same way.
So where do we see this stuff in action? Well, it's the backbone of tactical tools like the battlefield surveillance system. It's used for highly specialized missions, like Project GIM, which is all about mapping border intelligence, or Project THAR to find hidden water sources out in the desert. And for logistics, it is an absolute game changer. We're talking planning fuel routes, water stops, and analyzing the safest passage for critical supplies. Let's make this really concrete. Meet Captain Aris. His mission? Move a convoy through a dangerous desert region. Now he's not pulling out a paper map. No way. First, he applies Layer 1, a proximity analysis, to immediately find all the nearby water sources. Then he applies Layer 2, a least cost path analysis, to find the single most fuel-efficient route for his specific vehicles. But here's the most critical part. Layer 3, a real-time data feed showing any potential enemy threats along that route. That right there is the power of GIS.
All right, let's pull all of this together and hit the highlights.
Okay, so here's the 1-minute recap. GIS is a powerful spatial system that turns raw location data into actionable intelligence. It's built on 3 key things: hardware, software, and a database. It works in a 3-step process: input, processing, and output. And its killer feature, especially for the military, is that layered architecture, which we saw in action for everything from finding water to planning complex logistics.
And that brings us to our final and I think most crucial question. The source material says that GIS provides mathematical assurances. Now I want you to really think about that. How does moving from a static paper map, which, let's be honest, is outdated the second it's printed, to a dynamic, layered digital map, how does that directly fight against the fog of war? How does it slash information delay and give commanders real confidence in their split-second decisions? That, right there, is the real reason this technology is such a profound game changer.